This is AP Calculus Lesson 2-7. We're talking about piecewise derivatives today, and you'll note that we are using a different form of taking notes. We are using a Windows machine. We'll see how it works. I don't know if it can handle trying to write to a solid-state drive and do all this stuff. We'll see. Okay, so the question we have, is f continuous at x equals 2? How do we do that? We have to check three things. So we have to check three things. Firstly, you have to check if, and I'm going to do my one right here. So you have to check that the limit of f of x as x approaches 2 from the left-hand side, that needs to be equal to f of 2. How do I read f of 2 without saying f of 2?
Value at 2.
Or the height of 2.
Height at 2, yeah. So it needs to be equal to the height at 2, so that's the second thing. Those two need to be set equal to each other. And all three of these things actually need to be set equal to each other. Let me make my equal sign, whatever, I'll go like that, is equal to the limit of f of x as x approaches 2 from the right-hand side, from the right. Have to check all three of those things. All right, so using our piecewise function up here, let's go ahead and do that. Let's calculate each three of these things. What is the limit of my function as I approach 2 from the left-hand side? Again, left-hand side should be that first piece. I need someone to answer.
7.
7. How'd you get 7?
Plug in 2 for x.
2 for x. 2 times 4 is 8, minus 1 is 7. Perfect. So I'm going to write down here in, let's do it in black. We'll say that that is 7. Okay, that needs to be equal to f of 2. What is the height at 2, arrow?
6.
6. Uh-oh, we're off to a bad start. You plugged in into this one because we had the equal to sign down here, right?
Yeah.
Okay, perfect. And this needs to be set equal to where x approaches 2 from the right-hand side, which is, shout it out, someone?
6.
6 as well. And that's because there's the same function. Sometimes what will happen is you'll have three of these, one where it's less than, one where it's greater than, and one where it's equal to. So that's why you do have these three checks. Sometimes two of these are included in one statement. And obviously these are not all equal, so what we want to write, we'll come back to blue, is that f is not continuous. At x is equal to 2, because it did not pass that check. So that is the piecewise continuity test. You have to check all three of these things, make sure they're all set equal to each other.
I think we already knew that, though.
Yeah, I think this is just making sure that we're a little bit more formal.
Okay.
Yeah, so let's go ahead, and I think we only have one more slide left from last year's slides, but in here I can just scroll down. So let's do the piecewise different. Oh yeah, so you're right, we totally did know that. That was review. I apologize. This is the new stuff, and you still have to check this one, but you also have to check this one. That's why we reviewed. So this is called the piecewise differentiability test. All right, so I'm going to, let's just use that same equation. So the same piecewise function, let's just rewrite it down here. So if you have f of x, actually, we'll write f prime of x. We don't want to rewrite it. Let's just take the derivative. So if it's differentiable, then it basically is the same thing, but take the derivative. So f prime of x, we still set up our piecewise function. So what is the derivative of 4x minus 1? Someone shout it out.
4.
4. So we say it's 4 for x values less than 2. Okay, Ben, derivative of the second part, the second piece of our piecewise function is
2x.
2x, where x is greater than or equal to 2. So very similar to our previous test, we have to check these three things. First, that the limit of f of x, f prime of x rather, f prime of x, as x approaches 2 from the left, is equal to, and you can probably guess what's going to be coming here. Second thing is it is equal to what?
F prime of 2.
F prime of 2, yep. F prime of 2. And is equal to the third thing, Ben. What is that going to be?
The right-hand limit. Limit f prime of x as x approaches 2 from the right.
As x approaches 2 from the right. Perfect. All right. So let's go ahead and calculate these things.
So does this actually get rid of sharp corners?
This does, yeah, because sharp corners are where you have a sudden change in slope. So right here, for example, I have a sudden change in slope. The slope was positive 1, positive 1, positive 1, positive 1, and then all of a sudden, the slope is now magically negative 1, negative 1. It doesn't gradually change. The limit of the slopes do not equal one another. Can we see that? So if I were to graph this one, so if this was a graph of f of x, I can draw an x, f of x, and then this is a graph of f prime of x, then what would happen is I suddenly have a positive slope, positive 1, and then all of a sudden, bloop, jumps down to negative 1, negative 1. So this would be the graph of f prime of x. Notice that the limit of f prime of, as x approaches 2 from the negative side, over here, well I guess it would be 0 instead of 2. But as I approach from the left-hand side, it does not equal the limit as I approach the right-hand side. There's this discontinuity in the graph of the derivative, which means it's not differentiable. But that might not be the case. Let's go ahead and calculate what f prime is as x approaches 2 from the left-hand side. What is that?
4.
It's going to be 4. Perfect. Ben, what is the height at f prime of 2? Or it's not really the height. What is the slope at 2?
4.
4, and therefore this right-hand limit is 4. All right, so this thing is differentiable if it was continuous, but we still have to say that f is not differentiable because it wasn't continuous. It has to satisfy both, right? Because part of the differentiability test is that it is both continuous and differentiable. But if it was continuous, then this would have proven that it's differentiable as well. Other things that I want to show you that's cool about this program is, I wonder if I can just use the backhand. So I'm going to flip my stylus over. It automatically detects it. Oh, okay, that's better.
Wow.
I mean, yeah, and it's the magic eraser. If I touch a line like this, boom, it erases the entire line.
So you're using the eraser side of the pen?
Yeah, the eraser side of the pen was not working for the Mac for some reason. Maybe it's just because I need to play with it more.
I think it wasn't working. It probably just wasn't working in that notebook software.
Yeah.
It's designed for the smartboard.
But one thing that the notebook software definitely did not have is the ability to erase if you just touch the line, the magic eraser. It just did pixel by pixel, and that caused a lot of lag. This one does not lag. All right, that's all I wanted to show you guys for the notes. Any questions? All right, then go ahead and write your summaries.